Earth movement and major landforms. The Earth's surface is highly uneven and irregular. The surface of the Earth is being shaped and reshaped by external agents like running water, wind, glaciers, etc. That is the reason why our present-day landforms are diverse and varied. What we see today on the surface of Earth is the product of millions of years of geological change. Earlier, all the continents formed a single mass. However, under the influence of forces generated within the Earth, they moved away in different directions. Such forces lead to slow movements and sudden Earth movements, which modify existing landforms. Forces which affect the Earth crust: endogenic forces, exogenic forces, sudden forces, dystrophic forces, erosional and depositional work by earthquakes, volcanic eruptions, landslides, mountain building, rivers, glaciers, wind, sea waves. The forces which originate inside the Earth and bring changes on the surface of Earth are known as endogenic forces. The forces which operate on the surface and bring changes on the surface are called exogenic forces. The endogenic forces try to uplift the Earth's surface, while exogenic forces try to level down the surface of the Earth. Earth movements. The powerful endogenic forces operating from within the crust are also known as tectonic movements. Tectonic movements can be divided into two types. Sudden movements. They bring abrupt changes on the Earth's surface. Earthquakes and volcanic eruptions are examples of these movements. The such changes can cause a part of land to be fractured or the course of river to be changed. Slow movements. Some changes in the Earth's crust are so slow that they take hundreds of years to become noticeable. They are called slow changes. The Mahabalipuram temple, which now stands in the sea, is an example of this movement. Slow movements are further classified into vertical and horizontal movements. The vertical movements cause uplift or subsidence of the Earth's crust. When a part of the Earth's crust is thrown up by an internal force, it results in an uplift. The uplifted portion may become a plateau or a continent. In the case of subsidence, the part of Earth's crust may sink in comparison to the surrounding region and give birth to a valley. Horizontal movements give birth to two forces: compression or pushing and tension or stretching. Such movements can cause folding and faulting of the crystal layers, thus creating mountains and rift valleys. Forces of compression. These forces act on rock strata from opposite directions, due to which the rock layers are bent or folded into a series of anticlines and synclines. These forces are responsible for the formation of fold mountains. The Himalayas, the Andes, the Alps, and the Rockies have been formed due to forces of compression and are examples of fold mountains. Forces of tension. These forces operate in opposite directions, thus causing a fault or fractures in the Earth's crust. The fractured rock strata either slides upwards or downwards along the fault line. The faulting then gives birth to new relief features like the rift valley or a block mountain. If a block of land is uplifted between two parallel faults, then it looks like a huge mountain, known as block mountain. If a block of land subsides between two parallel faults, a trench is thus created, which is known as rift valley. Major landforms. The landscape is being continuously worn away by two processes: weathering and erosion. Weathering is the breaking up of rocks on the Earth's surface. Erosion is the weathering away of landscape by different agents like water, wind, and ice. The eroded material is carried away and eventually deposited. The process of erosion and deposition creates different landforms on the surface of the Earth. Work of a river. When the river tumbles at steep angle over very hard rocks or down a steep valley side, it forms a waterfall. As the river enters a plain, it twists and turns, forming large bends known as meanders. Due to continuous erosion and deposition of the sides of meander, the ends of the meander loop come closer and closer. In due course of time, the meander loop cuts off from the river and forms a cut-off lake called an oxbow lake. At times, the river overflows its banks. This leads to flooding of the neighboring areas. As it floods, it deposits layers of fine soil and other materials called sediments, along its bank. This leads to the formation of a flat, fertile floodplain. The raised banks are called levees. As the river approaches the sea, the speed of the flowing water decreases, and the river begins to break up into a number of streams called distributaries. Each distributary forms its own mouth. The collection of sediments from all the mouths forms a delta. Work of sea waves. The erosion and deposition of sea waves gives rise to coastal landforms. Sea waves continuously strike at the rocks. As a result, cracks develop and become wider. Thus, hollow-like caves are formed on the rocks. They are called sea caves. As these cavities become bigger and bigger, only the roof of the caves remain, thus forming sea arches. Further erosion breaks the roof and only walls are left. These walls-like features are called stacks. The steep rocky coast, rising almost vertically above seawater, is called sea cliff. The sea waves deposit sediments along the shores, forming beaches. Work of ice. Glaciers are rivers of ice which do erode the landscape by bulldozing the soil and stones to expose the solid rock below. As the ice melts, the eroded surfaces gets filled up with water and become beautiful lakes in the mountains. The materials carried by glacier, such as rocks, sand and silt, gets deposited. These deposits form glacial moraines. Work of wind. An active agent of erosion and deposition in the deserts is wind. Wind erodes the lower section of the rock more than the upper section. Therefore, such rocks have narrow base and wider top. It lifts and transports sand from one place to another. When it stops blowing, the sand falls and gets deposited in the low hill-like structures. These are called sand dunes. When the grains of sand are very fine, the wind can carry it over very large distances. When such sand is deposited in large areas, it is called loess. Volcanoes. People generally think of a volcano as a mountain that ejects lava and flames of fire very often. However, volcanoes are openings in the Earth's crust through which materials are thrown out from the interior of Earth. The materials thrown out include hot molten rock or lava, along with ash, some solid rock particles, steam, and gas. The opening is called a vent, around which a conical mountain may be formed. The funnel-shaped basin surrounding the vent is called a crater. A volcanic eruption along a linear crack called a fissure is called a fissure eruption. The whole process of ejection and solidification of lava is called volcanicity. So long as the hot liquid material of the volcano remains within the surface of the earth, it is called magma. But when this magma rises to the surface of the earth, it is called lava. The lava flow depends on its viscosity. The amount of silica and water in magma affects the viscosity of lava. High viscosity of lava is associated with greater amount of silica and less of water, and vice versa. Kinds of volcanoes. According to the nature and frequency of eruptions, volcanoes have been divided into three categories: active volcanoes, dormant volcanoes, extinct volcanoes. Active volcanoes. These volcanoes erupt frequently. There are more than 500 active volcanoes in the world. Most of them are found in a circular belt around the Pacific Ocean called the Ring of Fire. Example, Mount Etna in Italy. Components of volcano. Layers of ash and lava from previous eruptions. Molten rock is called lava when it comes out to the surface. It flows down the mountainside as lava flow. Crater, a funnel-shaped hollow at the top of a volcanic cone. Steam, gas and dust. Volcanic bombs, lumps of molten rock that solidify as they fall. Falling ash, small pieces of shattered rock thrown out of the volcano. Secondary cones form if the main vent is blocked and the magma is forced to the surface by another route. Main vent. Magma chamber, a store of molten rock deep inside the earth. Dormant volcanoes. These volcanoes have not erupted for a long time. They are also called sleeping volcanoes. They may erupt, though they have not done so, in a long time. When they come to lift, they can be very destructive. Example, Mount Vesuvius in Italy. Extinct volcanoes. These volcanoes are dead and inactive. There is virtually no movement. The peak of these mountains is now covered with ice. Example, Mount Kilimanjaro in East Africa. Earthquakes. An earthquake is a sudden and violent shaking of the Earth's surface, which usually originates from the interior of the Earth. Most earthquakes are caused by the movements of the plates of the lithosphere. An earthquake usually lasts for only a few seconds, but may be violent enough to cause extensive damage to life and property. The point at some depth below the Earth's surface, where the vibrations of an earthquake begin, is called the focus. From there, the vibrations spread in all directions, much like the ripples caused by the dropping of a stone into a pool of water. The point on the Earth's surface that lies directly above the focus is called the epicenter. The vibrations reach this point first and then spread outward over the surface. Thus, the epicenter usually suffers the maximum destruction. Measuring earthquakes. The earthquake waves are recorded by an instrument called seismograph. The science of earthquake is called seismology. Seismologists are experts who study the pattern of earthquakes. The Richter scale, designed by an American seismologist, Charles Richter, is used to measure the magnitude of an earthquake. This scale has a range from 0 to 9. The higher the number on the scale, the greater the magnitude of destruction. Earthquakes measuring above 6 on the Richter scale are very destructive. Although earthquakes cannot be predicted, their impact can be minimized if we are prepared beforehand. Some common earthquake prediction methods adopted locally by people include studying animal behavior. Fish in the ponds get agitated and the snakes come to the surface. Earthquakes are experienced in the same belts where volcanoes are situated. This is because the Earth's crust is very unstable in this region. Earthquakes do not create major landforms. However, they cause changes in the existing landforms. For example, they may cause cracks to open up in the ground. They may also lead to landslides or cause giant waves in the ocean called tsunami. Earthquake at BHUJ. A case study. A powerful earthquake measuring about 7 on the Richter scale hit the Indian state of Gujarat on 26 January 2001. It caused great damage to life and property, killing more than 20,000 people and destroying nearly 4 lakh houses. About 16 million people were directly or indirectly affected by the earthquake. The earthquake had its epicenter near Bhuj in Kutch, Gujarat. The region around Bhuj, therefore, suffered the maximum damage. Going by the previous records of earthquakes, the risk of violent and destructive earthquakes is very high in the Bhuj region. So, the rules for constructing quake-resistant buildings should have been strictly followed. This could have restricted the collapse of buildings, which is the main cause of deaths in an earthquake. Besides, the Bhuj region is very densely populated, which is another reason for the large number of deaths. In India, we have experienced many earthquakes in the Himalayan region. The Deccan Plateau has experienced some earthquakes of mild intensity and is considered relatively safe from earthquakes. Some destructive earthquakes that have rocked India are 1991, Uttarkashi, Uttarakhand; 1993, Latur, Maharashtra; 1997, Jabalpur, Madhya Pradesh; 1999, Chamoli, Uttarakhand; 2001, Bhuj, Gujarat; 2005, Jammu and Kashmir. Year, place.